All right, everyone, let's go ahead and get started. So before we begin, please feel free to comment in the chat, put in questions. We do have Gabby, our chat moderator, who will be helping me out with that. And be sure to like our our YouTube. And yeah, we're going to have a great time. So welcome to Security Through the Dark Web. I'm Heather Hodges, Senior Open Source Instructor for the Technical Operations Group at BlackHorse Solutions. At BlackHorse, our operating group provides several training and readiness courses in commercial best practices for conducting digital research using advanced and safe research techniques. Now, part of that training is to provide a foundational understanding of the hidden areas of the internet and digital identity on the dark web. For this webinar, we've taken segments from our dark web seminar and our dark web immersion course to focus on the dark web as a means to a secure end, to mask our digital footprint and provide privacy and security when accessing the dark web. Oops, gotta click the slide. So our agenda for today, an internet revolution. A quick vignette on how the dark web has been used successfully in the past. We'll talk about key terms, myths, and legalities. Tor, the most common dark web currently in use. Onion routing, how the Tor network works. Onion services, the websites contained within the dark web. And use cases for Tor and the dark web. Now, before we begin, I want to give everyone an opportunity to follow along with this webinar. So if you would like, go to thetorproject.org and download the Tor Browser bundle. The link is provided in the description below. Simply go to the Tor Project main page, select Download Tor Browser, and then select the download for your current operating system. Don't worry, this is a completely safe and secure application, and I'll be showing you ways to utilize the browser for personal security and to safely search the dark web. So I'll give everyone just a minute in case anyone wanted to do so, and you guys can let the download run while we get started. Okay, let's go. An internet revolution. In December of 2010, a man named Mohamed Bouazizi set himself on fire to protest the taking of his vegetable cart by the Tunisian police. This was the catalyst that sparked the Arab Spring, which was a series of pro-democracy uprisings that took place across the Middle East from 2010 to 2014. So, attempting to suppress the growing number of protests, the governments of those countries implemented censorship campaigns and throttled access to the most important line of communication, the internet. Now, Anonymous, the decentralized hacktivist group, wasn't going to have it. So they launched Operation Tunisia to restore access and aid in the flow of communications to outside of those protesting countries. They distributed digital care packages that included the Tor Browser bundle. That's the pre-configured browser that hopefully you just downloaded that enables access to the Tor network, or more commonly known as the dark web. Armed with Tor, the users of the people were able to bypass the proxy detection systems implemented by the government and access the World Wide Web. Now, even though Tor had already been used to bypass censorship in the past, this example is significant because it was the first time that uprisings of this size and magnitude relied on social media as a key factor in organizing and demonstrating. And Tor was a pivotal avenue to provide that freedom of access and expression. and allow the demonstrators, who were frequently targeted by the police, to do so anonymously. Now, before we continue, we need to define a few key terms. And a big shout out to my best friend for this analogy, because it is the best analogy to explain the levels of the internet that I have ever heard. So first we have the surface web. So this is the level of the internet that we access simply by turning on our computer and opening a standard internet browser. These are the files and websites that are available through traditional search engines such as Google or Yahoo or Bing, or open social media such as Reddit and Wikipedia. No special software is necessary to access these sites. Now, the deep web can also be accessed through a standard internet browser. But in order to access the websites and files contained within, we need a different fishing pole. We need to log in. We need to solve CAPTCHAs, or we need to know the websites exist because they are not indexed by Google or other search engines for whatever reason. Finally, we have the dark web. Now, to get to the dark web, we need a submarine, a tool with special features that will allow us to view websites that aren't accessible through traditional internet browsers. So, as we saw in the Arab Spring, the dark web, in one instance, is a tool to allow people to bypass internet censorship in order to access the World Wide Web. But what is a dark web? So a dark web is a hidden network that runs on the backbones of the open internet. Specific network configurations are required to access that portion of the web. They are private communication networks where communication takes place without revealing identifying information, such as who is talking to whom or where the communications originate and terminate. So let's dispel the first myth about the dark web, and that is that the dark web is only a gathering place for criminals. Now, criminals do utilize the dark web, as we all know, but they're not the majority. And anonymous crime wasn't the purpose of the dark web at all. Even though it should be mentioned that the very first transaction on the dark web was completed by university students who were developing the Tor network, who used the network to exchange marijuana. So either way, that was not the original purpose for the dark web. In the late 1990s, research organizations for the Department of Defense supported the effort to create an encrypted and anonymous network that was not available to traditional or to standard internet users, to create a network that could secure the communications of US spies. Now, this idea was never fully realized, but something much more valuable arose. It became a network to protect the anonymity of human rights and privacy activists. In other words, the mission of the dark web became an initiative to prevent censorship, maintain privacy, and protect from the surveillance of authoritarian governments. A study released late last year sought to answer the question of whether the social benefits of Tor as a privacy-enhancing tool and a censorship circumvention technology outweighed the cost, which was the use of the system as an anonymous platform for illegal activities. The study found that only about 6.7% of users globally access Tor to surf onion services or dark websites. Most are using the network's privacy and security features to access the clear web. Now, it should also be mentioned that these percentages do change based on the company we're talking about, or the country we're talking about. So, for example, in free countries, they found that that percentage was much higher in users accessing onion services and therefore potentially using the dark web for illicit activity. Whereas in oppressed nations, it was much less, ensuring that they were actually using the dark web for access to the clear web. So that brings us to our next myth, that it is illegal to access the dark web. Also part of this myth is that the FBI will keep a list of anyone who downloads the Tor browser. The FBI thinks this is very funny because they definitely do not have enough agents and they definitely don't make enough money to monitor every single person that downloads the Tor browser bundle. And also, they more than likely don't have access to those metrics anyway. So the dark web is not illegal to access, but because of its anonymized and secure nature, it is a logical haven for criminals. Drugs are for sale on marketplace websites. You can find other illegal activities such as hackers for hire or hitman services. I just read an article the other day about two men in Finland being arrested and charged with Finland's first dark web contract hit. So these things do happen. But that's not just a dark web problem. This is a clear web problem as well. The dark web is only 1% of the internet. The deep web, or the level of the web that we have to access with CAPTCHAs and usernames and passwords, is 96% of the internet. So it is much more likely to find these types of services on the deep web than it is on that 1% of the dark web. And there are other uses for Tor that aren't illegal. People need privacy for a number of reasons, such as citizens in nations that censor the internet and journalists working with whistleblowers, whether or not we agree with that or not. Now, some organizations have published content on the dark web in order to provide access where they might otherwise be censored. For example, Facebook, ProPublica, and the New York Times all have a presence on the dark web. So let's dig a little bit deeper into Tor, the onion router. So Tor was technically the first dark web. It was the first dark web that was put into development, even though Freenet, another dark web, was released first. But in 1995, that makes Tor the oldest dark web. The U.S. Naval Research Laboratory began development of the Tor network, and they released that network in 2002 to the public under a free and open software license. So this means that it was free to own and that the code is openly available. So anyone can review it, from Tor developers to security researchers to Tor enthusiasts alike. Next, in 2006, the Tor project was founded. It is a civilian nonprofit organization, and the NRL actually passed Tor maintenance over to the Tor project officially. Then in 2008, they developed the Tor Browser bundle. So this milestone brought access to one of the most up-and-coming private communication networks to the general public, regardless of computer or networking aptitude. And that is what makes Tor stand apart from the rest of the dark webs. So why do people choose Tor? We know that Tor is not the only dark web. There's Freenet, ZeroNet, I2P, and LokiNet, just to name a few. Yet Tor is the #1 dark web with more than 2 million users directly connecting to the network daily. Most of the other dark webs just aren't as accessible. Tor is easily downloaded with that pre-configured browser, with network configurations already installed onto the system. It is built on top of Firefox, making it an easy-to-use browser for those already familiar with standard internet browsers. And the Tor browser also comes pre-installed with browser extensions that allow for privacy and security within the browser itself. And finally, it can be used to surf both the clear and dark webs simultaneously without having to make changes to the configuration of the browser. Now, for those of you that downloaded Tor, go ahead and install it if you haven't already. When you have it installed, you should see that 2 icons were added to your desktop. You should have a Start Tor Browser executable and a file folder called Tor Browser. If the executable didn't pop up on the desktop, open the Tor Browser folder and the executable is located within. So when you first connect to the Tor network, it will ask you if you want to connect or configure. So you want to click Connect to continue. And once the Tor browser connects to the Tor network, you should see the browser homepage. And I'll give everyone just a second to get with me if you guys are following along. Okay, so the first thing that you should always do when you open the Tor browser is you should check to make sure that your browser is up to date with the latest software and security patches. Now, I know probably some of you just downloaded this, but go with me here. In order to update the Tor browser, you want to select the hamburger menu in the upper right-hand corner, then select Help and About Tor Browser. A pop-up will appear that states the Tor browser is up to date, or it will automatically start downloading the update that you need. So I'm going to open my Tor browser, go to the hamburger menu, select Help, then About Tor Browser. And my Tor browser is up to date, so everyone should be on Tor browser version 10.0.14. So while you guys are checking the update or waiting for the update to download, I want to draw your attention to the address bar. So we're going to orient ourselves to the browser. First, you have the address bar. You'll notice that it says search with DuckDuckGo or enter the address. So DuckDuckGo is a privacy-focused search engine that does not store search queries or track any of its users. It should be noted, though, that the search bar with DuckDuckGo will only search the clear web. It will not search the dark web. We have to go to special search engines for that. So next, we have the security shield. So this is a visual display of our security settings, and it provides a quick access to the security menu by clicking Advanced Security Settings. So when we look at those settings, there are 3 options: Standard, Safer, and Safest. The default configuration is always Standard, and this means that all Tor browser and website features are enabled. Specifically, what it means is that JavaScript, which is a computer programming language that enables functionality on websites, will be allowed to run on all the websites you visit. So this can be a problem when you're browsing onion services or dark websites because malware can be embedded within JavaScript. So for security, a general rule of thumb is that if you are using the Tor browser to surf the clear web, you should probably use the standard security level. That way you're able to use all the functionality of the websites that you visit. if you are visiting the dark web, it is highly recommended that you always use the safest security setting. This will disable JavaScript on all websites and disable some fonts, icons, math symbols, and images that are susceptible to malware intrusion. It will also prevent audio and video from automatically playing on those websites. So, in order to maintain our privacy and security on the Tor browser, there are some things we should know about it. We need to prevent user error. So some of the things we're not going to do is we are not going to use Tor for Google search. Google collects information like your search requests and your browsing patterns and your browser fingerprint and stores cookies within the browser. Google exists to track you, so we are not going to use the Tor network in order to search Google. We'll use a standard internet browser for that. The next is don't install additional browser add-ons. So Tor includes the browser add-ons HTTPS Everywhere and Noscript. HTTPS stands for Hypertext Transfer Protocol Secure. It is the secure version of HTTP, which is the protocol used to send data between a web browser and a website. So if you're probably familiar with this, you see in your URL that it's https:// and then whatever the URL actually is. So the secure version, it adds encryption to the data transmissions when visiting supporting websites. So any website that starts with HTTPS. What HTTPS Everywhere does, say that 3 times fast, is it ensures that protocol is forced where it is available. So that if websites have an HTTPS version and an HTTP version, it will force the use of HTTPS. So the next one is Noscript, and Noscript is the add-on that disables JavaScript in the browser based on your security settings. Installing this additional software onto the Tor browser can compromise your privacy and security because new add-ons that are not tested by Tor developers or the Tor project may affect the Tor browser in unknown ways and make your Tor browser fingerprint unique. So we've mentioned this a couple of times. Let's talk about browser fingerprinting. So browser fingerprinting is a form of tracking on the internet. Imagine that it's a snapshot of your browser. So it takes all the settings, all the configurations, the screen size, the fonts that are installed, the different types of plugins that are running on the browser, and so much more. So it can be incredibly unique to a user. But the way the Tor browser works is that everyone uses the same configuration. So you hide amongst the masses because everybody looks the same. So next is don't use Tor for torrenting. For those of you that don't know what torrenting is, it's a file share service. So think about the Pirate Bay and downloading pirated movies and music and books and whatever else. The most popular way to do this is by using a torrent client or a software that allows torrent file sharing. So the way that works is that files are hosted on multiple computers in a peer-to-peer network. So we're all directly connected to each other and we all have the same file on our computer. So when a downloader requests a file, then those files are broken down into smaller pieces and are uploaded from many users. All right. So small pieces all going at the same time to the downloader, and then they're reassembled by the torrent software client. So this makes downloading much faster than just downloading an entire file all at one time. But the problem is that using the torrenting software bypasses Tor's security features and could reveal your true IP address not only to the torrent client, but also to the other peers on the network. Finally, the last one is more of a, hey, you don't have to do this anymore. Don't worry about maximizing your screen. This is probably one of the most common things that people know about the dark web browser. And that is, oh, I can't maximize my screen because my browser fingerprint will be unique then. There's a lot of security blogs that still preach this, and it's probably one of the number one things that I read about the Tor browser. But the truth is, you don't have to do that anymore, because as of Tor browser version 9, they implemented a fingerprint defense called letterboxing. So what letterboxing does is it creates these white margins around the viewing window. And it ensures that no matter how you resize your browser screen, that the viewing window is always a standard size. So it eliminates the unique fingerprint that would have been left behind by a custom screen size. So no matter how I resize this, that Tor browsing window will always be a standard size. All right. So you can see what this looks like. So here, this is the base size. The Tor browser window will always open to the same one. And if I maximize the screen, you will see these white margins that appear around my Tor browser. All right. So let's move on to onion routing. So this is how the Tor network provides anonymity and security. So the Tor developers envisioned a network that was decentralized, operated by diverse entities and different trust assumptions. This helped to create transparency and separation and ensure that no one node could be the single point of failure in the network. So what this protocol does is it encrypts messages and requests in 3 layers. The messages, when they traverse the Tor network, travel through multiple nodes. And at each node, a layer of encryption is decrypted. And then finally, the idea that no node knows both the origination and the destination. So let's take a look at this. So when you connect to the Tor network, you are assigned a minimum of 3 relays. First, there's the entry node, or the entry guard. Second, you have the relay node, also called an intermediary relay. And then finally, you have the exit node, if you are exiting the Tor network in order to access a clear web website. If you are staying on the Tor network, such as visiting an onion service, then the exit node becomes just another intermediary relay. So these relays are chosen at random by the Tor network protocol. And remember, we said that Tor traffic was encrypted 3 times. So what happens when these relays are selected is they send their public key back to the Tor browser. And the browser uses those keys to encrypt your traffic 3 times, so that when we send our traffic, a layer of encryption is decrypted at each node, peeled away like an onion. This ensures that no relay knows both the origination and the destination. They only know where the packet came from and where it's going to next, but that is not necessarily the original origination point or the final destination. So let's think about this in another way. I need to get you to a safe house. And in order to do so without compromising the safe house location, I need to build a secure route. So what I'm going to do is I'm going to call you 3 taxis, and I'm going to handcuff your secrets to your wrist. The first taxi will pick you up at the origination and drop you off at a random point. From that point, the second taxi will pick you up and will drop you off at another point. From there, the third taxi will pick you up and drop you off at your destination, where you will then be able to decrypt or unlock your secrets and conduct your business. In this case, accessing and interacting with a website. So in that scenario, my route is completely secure because no single node knew the entire route to begin with. So your path is safe through the Tor network. Now we can see what this looks like on the Tor browser when we actually visit a clear web website. So here we visited protonmail.com, and you can click the link, the lock in the address bar here, and you will see your Tor circuit. So in this instance, the browser connected to the Netherlands, which was the entry guard. Then it connected to France, which was the intermediary relay, and then to France again, which was the exit node, all the way to protonmail.com. Information is then routed back to us in the reverse direction using the same nodes. Now, things will look a little bit different when we actually access an Onion service, so we'll talk about that when we actually get there. I want to return to the address bar for a moment to look at the last button, and that is the new identity broom. So this will make much more sense now that you're familiar with Onion routing. So when you click this broom, it will ask you if you want to shut down the Tor browser and restart it. So in other words, it sweeps away your tracks. It will, when you shut down and restart the Tor browser, you will be assigned a new middle relay or intermediary relay and a new exit node. Your entry guard will not change. This is because of an anonymity breaking attack on Tor that affects entry guards. So your entry guard will not change until every 2 to 3 months. If you'd like to read more about that, we can actually show that by we'll go to protonmail.com. So a little bit of a live demo here. And if we click that lock, you can see it says your guard node may not change. If you click learn more, then you can learn more about that Tor browsing attack. And a couple of use cases for this button might be if you feel your Tor identity has been compromised for whatever reason, or if you have unwittingly visited a malicious or illicit website. So along the lines of protecting your identity through Tor, let's dispel another myth, that you should always use a VPN with Tor. The Tor project does not recommend using a VPN with Tor unless you are an advanced user who knows how to configure both in such a way that will not compromise your anonymity. Most people, when they talk about using a VPN with Tor, they are talking about Tor over VPN, which means you first connect to the VPN and then you connect to the Tor browser. Now, this creates an extra VPN hop between you and the Tor entry guard. So if someone were looking at your traffic, such as your ISP, it would look like regular VPN traffic. An advantage here is that if someone does manage to break Tor, which has never happened before, and is able to see your IP address, then your VPN would actually protect you. Also, the Tor entry guard will only see the IP address of the VPN server rather than your true IP address. But there are some problems with this. So if your IP address, if your VPN drops connection, then your IP address, or then your Tor traffic is still exposed to the VPN. Now they can't see what you're doing on the Tor network because it's all encrypted, but they can see that you're accessing the Tor network. Also, some VPNs log internet activity, and so they would still log that you were accessing Tor. And therefore your activities would still be exposed. To quote a Tor developer, using a VPN with Tor is usually unnecessary, hardly helps, and hardly hurts. Better questions to ask are, who is your adversary and what is your threat model? If your adversary is your ISP, knowing that you're using Tor or you're in a country that censors Tor, there are better ways to address this. So we can use Tor bridges. A bridge, also called a bridge relay, is an entry point into the Tor network that is not publicly listed in the Tor main directory. The idea here is that if your ISP is filtering for known Tor relays, that it would not be able to prevent connections to all the bridges. So bridges can be configured in the options menu. Select the hamburger menu in the upper right-hand corner and then select options. You will be presented with a list of menu options and select Tor. Then under Tor settings, you will see bridges. If you check use a bridge, you will see there are 3 options. Select a built-in bridge, request a bridge from the Tor project, or provide a bridge. So if you select a built-in bridge, you will see 2 elements in the drop-down menu called OBFS4 and Meek Azure. What these are pluggable transports, and they obfuscate Tor traffic in such a way that it no longer looks like Tor traffic. This is to prevent deep packet inspection at the ISP level, ensuring that it could pass through any types of detection and filtering. When we combine this with the technology, with the bridge technology, then the likelihood that traffic will bypass the filters and inspection at the ISP and connection to the Tor network will be successful. This is a tactic that they utilized during the Arab Spring to connect to the internet. So back to the question, should I use a VPN for Tor? The answer is you don't really need to. If you are concerned with the trustworthiness of an entry node or concerned with censorship or scrutiny by an ISP, then a bridge relay is a more secure and reliable way to go about that. All right, so let's talk about onion services. So this might be my favorite part of the brief, and I see that we have only about 15 minutes left, so I'm hoping I can show you as much as possible. So we can access the clear web. We've discovered that. But how do we access the dark web? So first of all, we need to find the websites that are contained within. We need to find onion services. The Tor network uses the .onion TLD. A TLD is a top-level domain like .com, .org, .edu, except for the Tor network, it's .onion. These websites are private, they are typically not indexed by search engines, and they use long, complex domains. There are 2 versions in use currently. There's version 2, which is a 16-character alphanumeric hash. Version 2, as of October of this year, will no longer be supported by the Tor network. So then you will see the most common onion address become the 56-character version alphanumeric hash of the domain. What this does is it prevents anyone from being able to guess that these sites exist. So anyone being able to scrape the Tor network would be at much more of a disadvantage. And it increased the level of encryption on onion services so that the operator could not be identified. So how can we find onion services? So this is a quick taste into our dark web course and our CASO course, which is our course for commercial best practices in digital research. So I'm going to show you some secrets. So hopefully my boss already got offline. So the first one is how we're going to find dark web links is we're going to look at dark web link lists. Dark.fail is the #1 dark web link list currently in use. And that is because the website verifies the links using PGP, which is pretty good privacy. It's a form of verification and encryption for websites and emails and things like that. So what it does is, because it verified these websites, you know when you go to one of these links that it is the website it purports itself to be. So if you go to the first URL, then you can guarantee that you will end up at Darknet Live, which is a news source on the dark web. This also lists different forums such as Dread, Recon, and multiple marketplaces, as well as clear web websites that also have onion addresses on the dark web. All right, so the real secret here. You can use Google Dorking to actually find onion sites. So this is something we teach in our advanced classes, and we use a protocol called Tor to Web in order to find these onion sites. So I'm going to open a standard browser, and we'll go to Google real fast, and we'll show you some tricks. So Tor to Web is a project that aimed to bring the contents of the dark web to the clear web. But you sacrifice all the security of the Tor browser when you access these websites. So we never recommend that you access any Tor to Web project websites. So they typically end in .onion. Something. So it could be .onion.to, .onion.ly, .onion.cat, .onion.dog. There are hundreds of them. But we can use that to our advantage using Google Dorking, which is using advanced operators within the Google search bar to filter and refine our results. So I'm going to use the cite operator, which will allow me to search for specific domains or TLDs. So I'm going to look for .onion.**. The asterisk is a wildcard that will allow me to find any of the TLDs in use by the Tor to Web project. So now let's look for something good. Let's look for email, password, email dump. Oops, we don't need that to all be capitalized. Okay, so even my colleagues don't actually know about this secret website that I found. So like I said, lots of secrets being dispelled today. All right, you can use Google filters to actually filter out these websites, and that's going to be really helpful. So you have your keywords, and you can use tools, you can search by time. But basically what you see is this onion address here that's got the recognizable URL, and then it says .onion and then .ly. So we can visit these websites on the dark web. So I found this website called Intel Repository. So this looks pretty interesting, linked to 1.4 billion email password dumps. So what I want to do is I'm going to open a notepad. I'm really big on notepads in all my classes. It's a great way to visualize. So I'm going to copy the link location of the Intel repository and paste it into a notepad. So what I need to do to make this website visitable on the Tor browser is I'm going to first delete the protocol. Okay, so we're going to delete the protocol. Then we are going to find the Tor to Web TLD. In this case, it's .ly, and I'm going to delete the .ly. I'm going to leave anything that follows the file path, which is anything that follows that /. So I want to save all of this, and I'm going to go onto the Tor browser, paste it into the browser, and hopefully, as long as the website is still up, then it will access this onion service. So this website has a lot of useful info. So if you're law enforcement or you're OSINT or you're a security researcher, this website is going to really help you out with a lot of information. It has a list of a number of sites. If you click on confidential and sensitive intel, You can see it's been updated as of 3/13/2021. Very useful information here, so a little bit of a secret for you. But that's how we use Google Dorking in order to find Onion sites of interest to us. Next is using Reddit. I always talk about Reddit because Reddit is the front page of the internet. And if you're not using Reddit, you are not researching the internet. You can just go to Reddit. You don't need a username and a password, and you can directly search it from the platform. So there's a search bar at the top. I just searched for onion link list, and the first link or subreddit that appeared, because Reddit is categorized into subreddits, was onion link list for the dark web from the subreddit OSINT. It was posted 5 days ago when I took this image, so that was a great post to actually find. There was also another list of the latest onion links from our onions. There are subreddits that are dedicated to Tor, to onion services, and to the darknet. And those are all going to be very useful places to find onion services. So let's return to onion routing for a minute. So I said that onion routing looks a little bit different when we're accessing onion sites. And that is because if you're at an onion service, you'll notice that the lock changes to an onion symbol. So here our browser connected to the Netherlands as the guard, Germany as the intermediary, and then Germany as the exit node. Then you'll see we have 3 relays. This is because onion sites connect to the dark web exactly the same way we do. That information traverses 3 relays and then meets us at a rendezvous point where we are able to view and interact with that website. This ensures the same level of security for those onion services and makes them nearly impossible to find unless the onion service has been misconfigured or the operator makes a mistake. Because the number one vulnerability on the dark web is user error, and that is how most people are de-anonymized. Other methods of access. So 50% of internet users worldwide access the internet using a mobile device. Because of that, it is important that we are able to access the dark web using a cell phone or another type of mobile device. In some countries, using a mobile device to access the internet is the only way to do so. So the Tor project collaborated on the Android Tor browser. This is the only browser that was actually built in conjunction with the Tor project. It allows all the same characteristics and features of the Tor browser, such as encryption, secure connection to onion sites, and can be used to surf the clear web as well. Now, the Tor browser also endorsed an iOS app called Onion Browser for iPhones. They did not create this, and because of the way Apple development of browsers actually works, they force the use of their proprietary WebKit for development. It does not provide all of the security features of the traditional Tor browser because it is still sending some form of information back to Apple. So, use cases. There are many use cases for Tor and the dark web. First, you can use the browser in your everyday life for secure surfing, to protect your data connections and information. Think of it as a free VPN. When you connect to the network, your data connections and information are completely secure and you are able to access the World Wide Web anonymously. So it is important to note that some websites will not like your Tor connection, such as banking websites, Netflix, Hulu, those kinds of paid services. They won't like it, so you could try to use a bridge, or sometimes you might have to switch back to a regular internet browser. Next is securing your internet traffic from your ISP. So a lot of people kind of wonder, why would I want to do that? And the answer is your ISP is collecting information on you, and they are selling that information about your browsing patterns to different advertising companies. So to prevent that and maintain your privacy, then securing your internet through Tor is an excellent choice. Secure logins for sites you normally use. So again, protected data transmissions, sites like ProtonMail and Facebook all have secure logins through Tor and recommend that usage for people that want to maintain that level of security. There's also anonymous chat and secure messaging services, so that way information can traverse privately and securely and secretively. And then finally, for those that are more technically astute, creating secure websites for information and file sharing. Your files will be completely encrypted. You can set timers so that they disappear. And if you don't tell anyone about your Onion service, there is no way that anyone is ever going to find it. So the likelihood of someone stumbling upon your Onion service is extremely unlikely. So to wrap up, whether you're logging into email, fighting for democracy, scrolling through forums, or applying to the CIA, the dark web is a place not only of criminal activity and illicit content, but real uses for everyday activities. Remember, the dark web was built for the privacy and security conscious. Developers are continuously building programs that utilize the anonymity principles of the Tor network, from Raspberry Pi servers to secure file sharing clients such as OnionShare, to operating systems such as Tails, the Amnesic Incognito Live system. It's a portable operating system that works off of a USB drive, has non-persistent storage, and is not forensically detectable. Is a very interesting browser to play with. And then there's also Unix, the anonymous operating system, which also utilizes all connections through the Tor network. But there are limitless uses for both Tor and the dark web. In our classes, in our dark web immersion course, we actually go into some of these operating systems in much more detail, and we discuss different levels of investigation as well as how to operate some of these programs and create devices such as your own Onion service or a Raspberry Pi as a file share server. All right. And with that, does anyone have any questions? I like that question. On a scale of 1 to 10 foil hat, how would I suspect or know if my browser was compromised? Well, that might be difficult to detect. If you go to a website and to an Onion service and you start to notice that other things are running on your computer, like your computer CPU is processing a lot of JavaScript or something like that, then I might change my identity. I definitely changed my identity every time I went to the Hitman service site and the Hackers for Hire, just because I want to randomize my point of presence. But other than that, sometimes you just gotta kind of go on gut feeling. Will there be a 2.0? We do have a dark web seminar that goes into much more detail in all of the things that I've discussed. As far as a 2.0, I don't know. We'll have to talk to my bosses about that. All right. Well, if no one has any more questions, thank you for attending our seminar. You can definitely contact me anytime at heather.hodges@blackhorsesolutions.com. If you're interested in any of our training, then go to togtraining@blackhorsesolutions.com. There is a link to the BlackHorse Tog website. I have our phone number listed and the addresses for our offices as well. We definitely open our dark web seminar to anybody. So if you're interested, hit up Tog Training and get some more information. All right. Thank you, everyone.